Hi, this is a very interesting problem. It says that it's called Atwood's machine in which two containers are connected by a cord of negligible mass passing over a frictionless pulley. So you see that the moment you have friction or a mass pulley with a mass, you will have other forces getting involved. If it is a pulley with a mass, there will be a rotational motion for the pulley, and so other forces will get involved. So we always write, massless and frictionless types. So at time t is equal to 0, container 1 has mass 1.38 gram, 1.3 kg, and container 2 has mass 2.8 kg. But container 1 is losing mass here, okay, as it moves. So there is a dm by dt component here. So that makes this problem slightly different. So container A is losing mass, and then we have to find acceleration at certain times, which is t is equal to 0 and t is equal to 3. Now we will write the equation here, which is again very normal pulley equations. T minus m1g is equal to m1a and m2g minus t is m2a. Acceleration direction is shown in the diagram. So acceleration is m2 minus m1 over m1 plus m2g. And we have a special scenario wherein m1 is losing mass, so dm1 by dt is minus 0.2 kg per second. So dA by dt is dA by dm1 into dm1 over dt. So dA over dm1 into dm1 over dt is dA by dt. Right, now we know dm1 by dt we have, so we have to find dA by dm1. Now dA over dm1 would be, this is a typical a minus x, a plus x dx scenario wherein it will be minus 2 m2 by m1 plus m2 whole square. Okay, so differential of this type you will see in a minus x over a plus x dx. So we'll put the value minus 2 m2 over m1 plus m2, and we have the value of dm1 by dt, okay, which is minus 0.2. So it's going to be, we are going to put these values. Now we have to find acceleration at t is equal to 0. So at t is equal to 0, m1 is 1.3 kg, m2 is, we have been given 2.8 kg. We'll put those values here and we'll get to know what is acceleration at t is equal to 0. We have taken as 9.8 meter per second square. That is 0.653 meter per second square. Now we have to find at t is equal to 3 seconds. Now at t is equal to 3 seconds, obviously a lot of mass m1 would have lost. So what is the value of mass m1 has lost? So what is the m0 for or m1 at t is equal to 3? So we have to find m1 at t is equal to 3. That is m1 initial minus dm1 by dt into 3 seconds, which is 1.3 minus, we have 0.2 kg into 3 seconds loss. So that works out to 0.7 kg. That is the mass of the object, that is the new m1. So we'll put this value of new m1 in this and we'll get to see what is the acceleration at t is equal to 3. and these new numbers work out to 2 into 2.8 into 9.8 into 0.2 over 1.3 plus 0.7 whole square. That works out to 0.896 meter per second square. Now you would have observed that acceleration is growing from 0 to 3 seconds. The reason being m1 is losing mass and acceleration is m2 minus m1 over m1 plus m2. So obviously m2 minus m1 grows as m1 keeps losing mass. Now the third question is, at what point acceleration will be highest? So acceleration would be highest when acceleration would be highest? When m1 is equal to 0, it can't really be negative, right? So A is equal to m2 minus m1. If m1 is 0, then you get the highest value, which is m1 plus, so m1 is the m1 at time t, and which is actually m1 initial, m1 original plus dm1 by dt into t. m1 original is 1.3 kg minus 0.200 into t is equal to 0. From here we get t is equal to 6.5 seconds. So at 6.5 seconds m1 would be 0, and that is the time when you will have highest acceleration for the thing. Thank you.